Hi friends, I am extremely happy to meet you all through this video lecture. Friends, in the last videos, I have already explained about the importance of mathematical physics in physical sciences and technology as well as the types of partial differential equations. Here, we shall principally discuss the solutions of these differential equations. The general methods of solution include method of separation of variables, integral solutions employing Green's function, method of integral transforms, and the method of numerical calculations. In many physical and engineering problems, we always seek a solution of the differential equation which satisfies some specified conditions known as the boundary conditions. The differential equations together with these boundary conditions is known as boundary value problem. If the boundary value problem consists of ordinary differential equations, let us first find the general solution and then determine the arbitrary constants from the initial values. But in the case of partial differential equation, the above process is not applicable since the general solution of partial differential equation cannot be found in any practical form. Even if such situation is obtainable, it will involve arbitrary functions and it is very difficult to fix these functions so as to yield a solution satisfying the given boundary conditions. A powerful method of obtaining solution of this type of partial differential equation is known as the separation of variables. The solution, which breaks up into a product of functions and each of which contains only one independent variable, is called method of separation of variables. Separation of variables is one of the several methods for solving ordinary and partial differential equations. The method of separation of variables is also used to solve a wide range of linear partial differential equations with boundary and initial conditions such as the heat equation, wave equation, Laplace equation, Helmholtz equation and biharmonic equation. The analytical method of separation of variables for solving partial differential equations has also been generalized into a computational method of decomposition in invariant structures that can be used to solve systems of partial differential equations. The method of separation of variables combined with the principle of superposition is widely used to solve initial boundary value problems involving linear partial differential equations. This method is widely used in finding solutions of large class of initial boundary value problems. This method is also known as the Fourier method or the method of eigenfunction expansion. One of the important applications of Fourier series is to obtain the solution of linear homogeneous partial differential equations together with the corresponding initial and boundary conditions. The steps involved in method of separation of variables are: Step 1. Finding factorized solutions. Step 2. Imposition of the boundary conditions. Step 3. Imposition of the initial conditions. Step 1. Finding factorized solution. In this step, the variables are separated. For example, x term and its derivatives together, y and its derivatives together, z and its derivatives together, and so on. Then, the separated variables are solved and its solutions are obtained. Step 2. Imposition of the boundary conditions. The boundary condition specifies the value that the solution must take in some regions of space and is independent of time. In this step, the boundary conditions are substituted to the above found solutions and the values of the arbitrary constants are obtained. Step 3. Imposition of the initial conditions. The initial condition is a condition that a solution must have at only one instant of time. In this step, the initial conditions are substituted and the required solution is obtained. Dear viewers, in this video, we have discussed about the theory of method of separation of variables and the various steps involved in it. The application of the method of separation of variables will be explained through the upcoming videos. Thank you.